Okay. So here we have unique concept interval signature. We have made a name return value prefix string. It is common to use a switch statement instead. We can use a switch to refactor the code and make it easier to read, more extensible if we wish to add more language support later. Okay. Write a test to now include a greeting in the language of your choice and see how simple it is to extend our amazing function. Okay. So that means we extend our test to include French. Cool. In the language of your choice. I read it in Tagalog. So here we add a constant equals to Tagalog. Okay. And then here we accept the language. We have to refactor this into a switch statement. If language switch. If case Spanish equals to Spanish hello prefix. So now we're just refactoring for If it's Spanish, change to the Spanish one. It's French. French hello prefix. And the default. There's no default. Okay. So now we added something, a case switch, a switch statement. Let's see. You could argue that maybe our function is getting a little big. The simplest refactor for this would be to extract some functionality into another function. Okay. I don't get it. Oh, there's a function that looks at the language. Okay. There's two functions, one that checks for the language and the other one that returns hello. Okay. Greeting prefix language string, and then returns a prefix. In here, we're going to take this and then that goes here. Return prefix plus name. And then this function is just going to check for the hello function. Return this function takes in this one. Okay. Fix. It accepts a language and then plus the name. Make the screen a bit bigger because it might be hard to see. Okay. So now it's saying that we have split the functionality into two because it's getting big. Oh, hey, I have a viewer. Hello. Hello, hello, hello. This will create a variable called prefix in your function. it will be assigned a 0 value. This depends on the type. For example, it's zeros. For strings, it is quotation. I don't understand why we're just returning nothing here. Let's see. A function name starts with a lowercase letter. Okay. Do you guys know why here this function is returning nothing in the like this return, this thing? Okay, I don't get it. Now you should have some understanding of Go syntax, bank functions. Yeah, cool. The test-driven development process: write a failing test and see it fail. So we know we have written a relevant test for our requirements, and seeing that it produces an easy to understand description of the failure. Okay. Writing the smallest amount of code to make it pass, then refactor. Cool. In our case, we've gone from hello to hello name, then hello accepts language. Of course, this is trivial to real-world software. The principle is still same. Test-driven development is a skill that needs practice to develop, but by breaking problems down into smaller components that you can test, you'll have a much easier time writing software. Cool. Okay. Create a test file called addertest.go and write this code. Addertest.go. Okay. Integers work as you'd expect. Let's write an add function to try things out. Create a test file called addertest.go and write this code. Source files can only have one package per directory. Okay. Okay, cool. Oops. So this should be hello world. then this too. Okay. Write the tests first. Damn, I have 3 people watching. Hello, hello, hello. Okay, now 1 just left. You'll notice that we're using %d. Okay, let me write the test. Test adder. Go back. Testing.t. Okay. If we run it, it's going to fail because we didn't declare what add is. Let's go test. Yeah. Hey, viewer, welcome. Welcome to the stream. I'm learning test-driven development in Golang. There's a really cool book called Learn Go with Tests, and that's what I'm doing right now. Trying to figure out how this whole thing works so I can get a job. No Go files in Learn Go with Tests. Huh. Did I not save them? Go test. Nope. Why is nothing working? Do I need to cd into the directory? ls cd integers go test. Ah, there you go. Because I was not in the right directory. So go test runs all of the files that end with test in the current directory. Okay. Yeah. Packet for got 0. In the strictest sense of TDD, you should now write the minimal amount of code to make the test pass. A pedantic programmer may do this. Ah, see. Damn, we have 6 people. Holy. Welcome everyone to the stream. I'm learning test-driven development and also learning Golang at the same time with this book right here. Learn Go with Tests. It's a really cool book. I'm enjoying it. Let's see. Let's fix it. Yes. So this function is going to add the 2 values. It aids the usability of the code. Okay, comments is / takes 2 integers and returns the sum of them. If you really want to go to the extra mile, you can make testable examples. Oh, so you can create example functions that are going to run when you run your tests. Okay. Cool. Go test. I didn't save it. Oops. Nope. I'll go test dash v. So where do I see the example function? Oh. Oh, I need slash slash. Here. Example.com slash. Oh, no, it was here. Examples without output comments are useful for demonstrating code that cannot run as unit tests, such as that which accesses the network while guaranteeing the example at least compiles. Okay. To view example documentation, let's take a quick look at package site. Navigate to your project's directory and run package site open. cd dot package site dash open. Period. Huh. Package site. It should open a web browser view pointing to localhost 8080. Inside here, you'll see. Okay. How do I see this? not working. Am I tripping? I'll get it. Inside, you'll see a list of all of Go's standard library packages, plus third-party packages you've installed, and I wish you should see our example documentation. Here's a finalized API for this chapter. Oh, this is what it would look like, okay. Polio covered, yes, 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 and yes, cool. Iteration. Holy, this should be better. So if you run the test, it shouldn't run. c /iteration. Yeah. Write the minimal amount of code for the test to run. Iteration. Wait, huh? Oh. I don't want to import testing. Here, I want to write the minimal amount of code for the test to run, which is the function. So here I write func iteration, which takes in a rune. Is that character? All you need to do right now is to make a compile so you can check if your test is written well. Yeah. Isn't it nice to know you already know enough code to write tests for some basic problems? It is. This means you can now play with production code as much as you like, and now it's behaving as you'd hope. Yes, it is. Enough code to make it pass. So here. Yeah, it should pass. Cool. Mm-hmm. Benchmarks. What is a benchmark? I see. Oh wow. Oh wait. Hi bro, what are you coding? Is this Rust? No, this is Golang. I'm going through the this book right here. It's called Learn Go It Tests. And basically um it teaches you Golang while also teaching you test-driven development. So, which is like a philosophy of like good practice in software development. So it's a really good book. I have actually wanted to learn Rust, but it's a bit hard for me because I don't know much about like memory allocation, pointers, and all that stuff. But it's something I want to do in the future. For now, though, this is my focus. So it's a really good book. Let's see. Yeah. So like right now, I'm learning about benchmarking and then unit testing. Let's see. Can you give me the link of this book? If you're interested, yeah, I'll put it in the comments. Hold up. I've actually never commented in my own chat. Is it here? It's not. I'm not too good with this. Hold up. I have to go on YouTube. Let's see. Is it here? It's not. There you go. I'm not too good with this. Hold up. I sent the link. I have to go on YouTube of my chapter. Let's see. Let's see. Is it here? It's not. There you go. I'm not too good with this. Hold up. I sent the link. I have to go on YouTube of my chapter. Let's see. Let's see. This is the good one. Is it here? It's not. Hey, I think it's mostly geared towards students. I sent the link who understand. I have to go on YouTube coding of my chapter. It's not too hard to follow. I feel like it just assumes you know a little bit. But it's a really good book for learning. This is the good one. Because testing is one of those things that is not are pretty overlooked. Oh my god, I hear myself. I think testing is one of the things that are pretty overlooked when it comes to software development. It's like, so having a book that teaches it on top of teaching the language, it's a double plus for me. Which part you found hardest? Oh, so far nothing. But I feel like sometimes it didn't. Let's see. The world. Actually, I take back everything I said. There's nothing really. It's nothing really complicated, actually. Yeah, no, like people should definitely read this book. I love it. There's exercises too at the end of each chapter, so that helps. There you go. Should definitely check it out. Amazing book. The only video I found where they taught unit testing was Intro to Python, CS50. Apart from that, no one teaches unit testing, but it's so important too. It's especially important because a lot of times you hear stories of people they run their software into production, and then that's when they realize everything's broken. But if you have testing, you can catch those errors before deploying your stuff. It's very, very useful. Also, have you done CS50? Because I've been thinking of doing it. Even though I have a CS degree, but CS50 is like complete, to my knowledge, at least. Repetitions. Yeah. I did the CS50 that's not Python. There's one that's like, hold up. The one by David Milan. CS50. I have done it, but if you have done a course of PS, then you can jump into more advanced courses, like Intro to Python, Intro to AI, and everything. Yeah. So what's funny is I've been studying over 2 years about like data science, machine learning, AI, and I realized that it's not for me. Like there's too much math involved. Linear algebra, it's so important. And also, I wasn't really interested in the mathematics part of it. So I was like, okay, screw everything. I'm gonna go back to software development fundamentals, start from scratch, learn like good coding philosophies, and start from there. Because I realize like AI is not for me, man. It's really not. There's too much math involved for me to like. My math foundations are not too strong. So, but yeah, we're going back to the basics. Full stack dev is more of my thing. Yeah, for sure. Well, what do you think? What do you think of front end though? Because I want to be a software developer, but I absolutely despise doing front end. Anything front end related, I want to kill myself. I'm in my last year of my degree, and whenever we have a team project, I'm just like, yeah, you guys do everything. I do not want to touch anything HTML. which is like deploying. Yeah, exactly. Deploying MLOps. But the problem is for MLOps, it's not really an entry position. Like you don't after graduation you don't really go into MLOps because you need experience like developing the models to deploy them. Kind of sucks because I'm into the software engineering part, but not the modeling part. So MLOps would be perfect. I love running from design to dev, also the animations, 3JS. Oh, I fucking love. Hold up. I keep seeing crazy websites. Is 3JS the 3D one? Or am I thinking of something else? Yes. Bro, these websites are so cool. But I know that it's a headache to make these. Oh, this is so cool. I think there's some some portfolio websites actually. They use 3JS for everything. It's so cool. Let's see. Wow. Look at this. So, oh, you can. Wow. Series level websites only good for showcasing real world cell animations. Sell the best. Really? Really, really. I guess these fancy ones are more for like for flexing more than anything. But yeah, subtle. I can see why. But this stuff is so cool. I don't know how it works. It's crazy, honestly. But yeah, wow. Wow. Before I used to be into front end CSS. I was pretty good at CSS, and then I just gave up. Anyways, cool stuff. Really cool stuff. Actual use case might be for product showcase. Oh shit. Other than that, I don't see its use case in real world. I feel like yeah, but I feel like a homepage. Oh, you mean product showcase to like show products like this, for example? Yeah. Some people I've heard people say that it's the future of web development in terms of like design. But you know, another part I've heard they talk about um how like minimalism and that stuff is taking over. Anyways, there's a lot of cool stuff you can do. Customize it. Why is music? Oh, whoa. You can customize it. This is cool. This is really cool. Wow. Hey, I wish I could do this. Damn. That's amazing. Oh, but I'm assuming you also have to be good at like 3D modeling, no? Blender and all that stuff is a skill, I think. Cool stuff. Wow. Wow. Okay. Let's see. So here, I need to write a test. Or actually, this test should work. Code test. It failed. Not enough calls, not enough arguments in the call. Oh, here in the benchmark. A5. Now if I run the test, should pass. Cool. Cool. Write example repeat. Document your function. I forgot how this worked. I'm not gonna lie. Example function. It starts with example. Okay. And you just copy this. So result equals 2. Result is, so we call the function test. And then how many times do you want to repeat it? Say 2. Okay. So now we've written an example. FMT. I should all be back. I think there's someone at the door. BRB. I'm learning to flex. That's funny. Yeah. Next big thing might be AR into websites using 3JS. Let's see. I can keep my chat.
Mm,
Uh, Pro.
Kubernetes, a tool for managing and automating containerized workloads in the cloud. Imagine you have an orchestra. Think of each individual musician as a Docker container. To create beautiful music, we need a conductor to manage the musicians and set the tempo. Now imagine the conductor as Kubernetes and the orchestra as an app like Robinhood. When the markets are closed, an app like Robinhood isn't doing much, but when they open, it needs to fulfill millions of trades for overpriced stocks like Tesla and Shopify. Kubernetes is the tool that orchestrates the infrastructure to handle the changing workload. It can scale containers across multiple machines, and if one fails, it knows how to replace it with a new one. A system deployed on Kubernetes is known as a cluster. The brain of the operation is known as the control plane. It exposes an API server that can handle both internal and external requests to manage the cluster. It also contains its own key value database called etcd, used to store important information about running the cluster. What it's managing is one or more worker machines called nodes. When you hear node, think of a machine. Each node is running something called a kubelet, which is a tiny application that runs on the machine to communicate back with the main control plane mothership. Inside of each node, we have multiple pods, which is the smallest deployable unit in Kubernetes. When you hear pod, think of a pod of whales or containers running together. As the workload increases, Kubernetes can automatically scale horizontally by adding more nodes to the cluster. In the process, it takes care of complicated things like networking, secret management, persistent storage, and so on. It's designed for high availability, and one way it achieves that is by maintaining a replica set, which is just a set of running pods or containers ready to go at any given time. As a developer, you define objects in YAML that describe the desired state of your cluster. For example, we might have an Nginx deployment that has a replica set with 3 pods. In the spec field, we can define exactly how it should behave, like its containers, volumes, ports, and so on. You can then take this configuration and use it to provision and scale containers automatically, and ensure that they're always up and running and healthy. This has been Kubernetes in 100 seconds. Like and subscribe for more, and you can support my work by sponsoring me on GitHub or by becoming
What is Kubernetes? Why is it called KAS? What makes it so popular? Let's take a look. Kubernetes is an open source container orchestration platform. It automates the deployment, scaling, and management of containerized applications. Kubernetes can be traced back to Google's internal container orchestration system Borg, which managed the deployment of thousands of applications within Google. Kubernetes. Why is it called KAS? What makes it so popular? Let's take a look. Kubernetes is an open source container orchestration platform. It automates the deployment, scaling, and management of containerized applications. Kubernetes can be traced back to Google's internal container orchestration system Borg, which managed the deployment of thousands of applications within Google. In 2014, Google open sourced a version of Borg that is Kubernetes. Now, why is it called KAS? This is a somewhat nerdy way of abbreviating long words. The number 8 in KAS refers to the 8 letters between the first letter K and the last letter S in the word Kubernetes. Other examples are I-18N for internationalization and L10N for localization. A Kubernetes cluster is a set of machines called nodes that are used to run containerized applications. There are 2 core pieces in a Kubernetes cluster. The first is the control plane. It is responsible for managing the state of the cluster. In production environments, the control plane usually runs on multiple nodes that span across several data center zones. The second is a set of worker nodes. These nodes run the containerized application workloads. The containerized applications run in a pod. Pods are the smallest deployable units in Kubernetes. A pod hosts one or more containers and provides shared storage and networking for those containers. Pods are created and managed by Kubernetes control plane. They are the basic building blocks of Kubernetes applications. Now let's dive a bit deeper into the control plane. It consists of a number of core components. They are the API server, SCD, scheduler, and the controller manager. The API server is the primary interface between the control plane and the rest of the cluster. It exposes a RESTful API that allows clients to interact with the control plane and submit requests to manage the cluster. SCD is a distributed key value store. It stores the cluster's persistent state. It is used by the API server and other components of the control plane to store and retrieve information about the cluster. The scheduler is responsible for scheduling pods onto the worker nodes in the cluster. It uses information about the resources required by the pods and the available resources on the worker nodes to make placement decisions. The controller manager is responsible for running controllers that manage the state of the cluster. Some examples include a replication controller, which ensures that the desired number of replicas of a pod are running, and the deployment controller, which manages the rolling updates and rollbacks of deployments. Next, let's dive deeper into the worker nodes. The core components of Kubernetes that run on the worker nodes include kubenet, container runtime, and kubeproxy. The kubenet is a daemon that runs on each worker node. It is responsible for communicating with the control plane. It receives instructions come from the control plane about which pods to run on the node and ensures that the desired state of the pods is maintained. The container runtime runs the containers on the worker nodes. It is responsible for pulling the container images from a registry, starting and stopping the containers, and managing the container's resources. The kubeproxy is a networking proxy that runs on each worker node. It is responsible for routing traffic to the correct pods. It also provides load balancing for the pods and ensures that the traffic is distributed evenly across the pods. So when should we use Kubernetes? As with many things in software engineering, this is all about trade-offs. Let's look at the upsides first. Kubernetes is scalable and highly available. It provides features like self-healing, automatic rollbacks, and horizontal scaling. It makes it easy to scale our application up and down as needed, allowing us to respond to changes in demand quickly. Kubernetes is portable. It helps us deploy and manage applications in a consistent and reliable way, regardless of the underlying infrastructure. It runs on-premise, in a public cloud, or in a hybrid environment. It provides a uniform way to package, deploy, and manage applications. Now, how about the downsides? The number one drawback is complexity. Kubernetes is complex to set up and operate. The upfront cost is high, especially for organizations new to container orchestration. It requires a high level of expertise and resources to set up and manage a production Kubernetes environment. The second drawback is cost. Kubernetes requires a certain minimum level of resources to run in order to support all the features we mentioned above. It's likely an overkill for many smaller organizations. One popular option that strikes a reasonable balance is to offload the management of the control plane to a managed Kubernetes service. Managed Kubernetes services are provided by cloud providers. Some popular ones are Amazon EKS, GKE on Google Cloud, and AKS on Azure. These services allow organizations to run Kubernetes applications without having to worry about the underlying infrastructure. They take care of tasks that require deep expertise, like setting up and configuring the control plane, scaling the cluster, and providing ongoing maintenance and support. This is a reasonable option for a mid-sized organization to test out Kubernetes. For a small organization, Yagni is our recommendation. If you would like to learn more about system design, check out our books and weekly newsletter. Please subscribe if you learned something new. Thank you so much, and we'll see you next time.
Think of Docker as a single shipping container. It packages
What's up everybody, it's Travis here from Travis.media. So back in 2019, I landed a job as a site reliability engineer. Prior to that, I was a developer. But this local company landed a big contract and needed a lot of people quickly. And so I was asked to interview for the position and I landed it. But I wasn't a site reliability engineer. It's a well-defined job title, but at this company, it was more like a person that is tasked to do it all. So my first task, or the first contract I found myself on, was containerizing applications and deploying them to Kubernetes. Well, I had no experience with Kubernetes. I thought I could learn it quickly, but I soon learned that I couldn't. Why? Because I didn't know the foundational concepts needed first before attempting to understand Kubernetes. It made little sense to me. I struggled with it because of my lack of understanding of the things you need to know first. So in this video, if you're learning Kubernetes, you're planning to learn Kubernetes, or your company uses it and you just want to get more familiar with it, I'm going to tell you what those concepts were that I lacked so that you can learn them and find more success in your journey of learning Kubernetes. So Kubernetes isn't going anywhere. In fact, it's gaining more and more adoption in the industry. Here's some stats. So the CNCF annual survey released in February 2022 with more than 3,800 participants from 6 continents produced this. Number 1, a record high of 96% of organizations are either using or evaluating Kubernetes, a major increase from 83% in 2020 and 78% in 2019. So a record high of 96% of organizations. Number two, 93% of organizations are using or plan to use containers in production. And then third, more than 5.6 million developers are thought to be using Kubernetes today. It's not going anywhere. It's a good time to learn it, but you'll need to know these foundations first. So let's go ahead and get started with that. And I'm either going to explain these concepts to you, or I'll point you to a free resource that I recommend that'll get you up to speed. So go and get familiar with these first, and then go head first into Kubernetes. And whenever you're ready to learn Kubernetes, be sure to check out the resource that I mentioned at the end of this video, as I think it's the best resource out there currently, hands down. With all that said, let's look at these prerequisites. Number one is the obvious. You need to understand containerization and the orchestration of containers. So here's the big picture. You deploy containerized apps and services to Kubernetes. Thus, it's paramount that you understand containerization. Now, Docker defines a container as a standard unit of software that packages up code and all its dependencies so the application runs quickly and reliably from one computing environment to another. So using Docker as an example, which Docker is a popular containerization platform, if you want to containerize your app, you'll first create a Docker file that has all the instructions for building an image of your app. So if you're containerizing a React app, you might start off with a node runtime, and then you'll add your package.json, then you'll add your command to npm install, then you'll add your code, then you'll add the npm run start command. That would be your Docker file. And then once you have this file assembled, you would use Docker to build these instructions into an image. And this container image is the blueprint for running your app. It includes everything you need to run it, all your dependencies, all your codes, commands, etc. And this image then becomes a container at runtime when you run it. So when you run the image, it's going to follow those steps. It's going to add your package.json, run npm install, copy over your code, npm run start, and your container's running. So if you go to an image repository like Docker Hub, you can find thousands of images that you can then pull down to your computer and run in a container. There's images for pretty much anything. So whoever has the image can run it and therefore have all the dependencies and everything needed for that app to run on its own in an isolated container. You can spin it up easily, you can spin it down, you can run it with multiple copies for high availability, and you can imagine the ease and portability of such containers. I give it to you, it works. You give it to me, it works. We're all running the same thing, the same blueprint with all of the same dependencies. Or let's spin up 5 and load balance between them. But how do these containers work in the big picture? Sure, it's nice to say you can run it locally and it works for everybody, but what's the big idea here? Well, that's where Kubernetes comes in. Kubernetes is an environment for you to orchestrate or automate the deployment, the management, the scaling, the networking of these containers. So prior to learning and tackling the basics of Kubernetes, learn the basics of containerization with an engine like Docker. It's free. Learn the basics of images and containers, building and running them, and containerize a few apps for yourself, and you'll be good. Now, I have a free YouTube video that teaches you Docker in 1 hour practically, and by the end of it, you'll have 2 containerized applications, a React app and a WordPress app, and I'll show you how it all works, how to download it, how to get started, basic commands, etc. So I'll put a link to that below or above. Be sure to check that out. That will get you up to speed. Now, the second prerequisite you'll need prior to learning Kubernetes is cloud basics. Companies often choose to deploy Kubernetes in the cloud as a managed solution. The cloud provider, AWS, Azure, etc., manages the Kubernetes cluster on its own virtual machines or servers. And then from there, it can tie into all the other services that that cloud provider offers, like identity and access, logging, networking, all of that. And if you want to revisit the stats that we mentioned at the beginning of this video, 79% of participants in that survey rely on cloud platforms for their Kubernetes hosting. So say you're working with Amazon's Kubernetes Managed Service, EKS, you'll need familiarity with cloud concepts like virtual machines and load balancers. So consider taking a basic cloud course, like the AWS Cloud Practitioner course on Udemy, to familiarize yourself better with their services that work with Kubernetes. Now, I do want to mention when you deploy Kubernetes in the cloud, it can get expensive quick without you even realizing it. If you're using or trying out a cloud-managed Kubernetes solution, or your company's currently using one, then today's sponsor, Cast AI, can be a very useful tool for you to get familiar with. Let me take a minute to tell you what is a dashboard, breaking things down over time by tags, labels, namespaces, etc. And third, you get a security report that scans your cluster for vulnerabilities and automatically prioritizes the fixes. And that's all free. If you move to a paid plan, then you get much more. You can set automation and it will, around the clock, monitor your cluster and rebalance pods to optimal configurations. And of course, like with any secure product, You remain in control with Cast AI's policies that allow you to specify rules upscaled and downscaled while there's no the paid YAML, which to take advantage of this deal today. Back to the video. Now, the third prerequisite you'll need to know before attempting to learn Kubernetes is YAML in declarative configurations. YAML, which stands for YAML ain't markup language, is a data serialization language for writing configuration files. It's a superset of JSON, and in fact, every JSON file is also a valid YAML file. Now, the resources in Kubernetes are created in a declarative way. You declare how you want things to be, and Kubernetes will make sure that it meets that declaration. And that declaration is provided in a YAML configuration file called a manifest file. This manifest file, again, describes the desired state of a Kubernetes object, and Kubernetes will make sure at all times that it meets that declaration. If you change a value, it will change its infrastructure accordingly. So here's an example of a deployment object written in YAML. This YAML defines a deployment object with 3 replicas. And there are 4 sections. There's the API version, which every object gets an API version. There's a kind, there's the metadata, and then there's the spec. The kind is deployment. The name of this deployment is Nginx deployment as indicated there in the metadata. And under the spec, you see the pod template specification indicating that the pods will run one container Nginx, and there will be 3 pods. And once this is defined, you run a kubectl apply command with this file in the argument, and the deployment object is created based on this configuration declaration. So YAML files are configuration files that house the declaration of your Kubernetes objects. You can learn the syntax very quickly with a tutorial like this. I'll put a link below to this. I think it's a good getting started YAML tutorial. But really, when you look up an object in the Kubernetes documentation, like I looked up deployments, there's so many examples for you to choose from. If you scroll down, it gives you lots of examples. You can just take this, copy and paste it, and then work from there. And that way you can figure it out on the go. Now, the 4th prerequisite before learning Kubernetes is to have a grasp of networking basics. Many developers have a weakness when it comes to networking, and it has nothing to do with them personally. It's just not really a huge requirement to writing code. It's more ops and system admin focused than it is developer focused. But Kubernetes requires at least a base understanding of networking because of all the moving parts and how everything's interconnected within it, and specifically Linux networking. In Kubernetes, there's communication between the pods and the containers within them. There's pod to service networking, and there's networking out to external destinations. And then the services have different service types like cluster IP, node port, etc. So you'll need to grasp networking concepts like OSI layers, protocols, IPs, DNS, gateways, routes. If you skip this, you'll find things complicated when you attempt to learn Kubernetes. Networking was a huge barrier for me, and a big reason why Kubernetes was so difficult at first. Now, if you take that Udemy course that I'm going to recommend you at the end of this, there's a great networking section in that course that covers DNS and Docker networking, CNI, TLS, and certificates. If you want to go more in depth with it, I'll link below to a 4-hour YouTube video that'll walk you through all of these networking basics. So when you have a free weekend, make sure you check that out. And the 5th prerequisite to learning Kubernetes is terminal proficiency, being good at the command line. To interact with your Kubernetes cluster, you'll use the kubectl or kubectl CLI. This will be the main way of managing your Kubernetes cluster from the terminal. Thus, you'll need to be proficient with Linux commands and with using the VI or Nano editor. You'll be using the terminal a lot. And then with kubectl, make sure you use a lot of aliases. For instance, never type the word kubectl like I've been doing. Always put an alias for the letter K. You want to get pods? K get pods. Or shorten it to KGP. So those are the 5 prerequisites. Make sure you have a good grasp on them. You don't need to master them. You don't need to spend a year on them. Just make sure you understand them well enough so when you bump up against them in Kubernetes, you'll know what to do. Now for this course recommendation, when you do get ready to learn Kubernetes, this is the best route to go in my opinion. The course that I took at the time and the course that I recommend is the Certified Kubernetes Administrator with Practice Tests course on Udemy. It's a real gem. Let me give you 3 reasons why. First, the instructor also runs Code Cloud, which is a wonderful site for DevOps, and you get to use all of their labs with this course. So you use their interactive terminal that's already set up. All the challenges will create pods and scenarios for you, and you'll be able to use that to solve all of the challenges of the course. This gets you hands-on and it gives you lots of practice with Kubernetes. There's like 12, 15 questions for everything you learn. Number 2, the core concepts section in this course is paramount for every beginner in Kubernetes. If you try to go to the Kubernetes docs to get the big picture, you're going to find it very difficult because there's a lot of moving parts like the scheduler, the proxy, the API server, the kubelet, and you're bound to get confused. This course gives you a really helpful visualization using boats and a dock to explain how all of the parts work. This explanation was the light bulb moment for me when first learning Kubernetes. And third, it's Udemy. There's a sale every couple of days, making this course like $14. Be sure you check out travis.media/Udemy to find out when the next sale is so you can pick this course up. So I hope this video was helpful. I hope you get through these prerequisites and learn Kubernetes and find success in your endeavors. So let me ask you, what prerequisite did I leave out? What do you think is required before learning Kubernetes? I'd love to hear it. If you want to leave a comment below, let's get the discussion going. If you found this video helpful, give it a thumbs up. If you haven't subscribed, consider doing so, and I'll see you in the next video.